So in our last class, we consider classification of polymers. So polymers are classified into 4 different types. Classification on the basis of source and structure, which are already discussed in our last class. Today, we consider classification on the basis of molecular forces and also classification on the basis of mode of synthesis. So first we start third one, that is classification on the basis of molecular forces. So on the basis of molecular forces, polymers are classified into 4 different types. Number 1 is called elastomers, second one is called fibers, third one is called thermoplastics, and fourth one is called thermosetting plastics. So there are 4 types of polymers on the basis of molecular forces: elastomers, fibers, thermoplastic, and thermosetting polymers. So first we consider elastomers. So what is elastomer? Elastomers are polymers which have elastic properties or elastic character like rubber. So if we apply force, so deformation takes place. If we withdraw force, then it again move in the original shape. So elastomers are polymers which have character like rubber, that is elastic character like rubber. So there are number of examples of elastomers. Number 1 is called vulcanized rubbers. That is natural rubber when heated with sulfur, 3 to 5% sulfur. So cross-linking takes place and it is called vulcanized rubber, which is also an example of elastomers. Second one, Bunayas, another example of elastomers. So Bunayas is an elastomer where monomer is butadiene and styrene and reaction takes place in presence of sodium. So Bunayas rubber where Bu stands for butadiene, S stands for styrene and reaction takes place in presence of sodium. So it is called butadiene styrene rubber, also known as Bunayas rubber, and reaction takes place in presence of sodium. So it is also an example of elastomers. Third one, Bunayas rubber, which is also an elastomer like Bunayas and vulcanized rubber. So if we conclude elastomers, so elastomers are polymers where elastic character like rubber, and there are different types of elastomers: vulcanized rubber, Bunayas rubber, and Bunayas rubber. Next we move second class of polymer based on molecular forces. So second one is called fibers. So fibers are polymers which have strong intermolecular forces between the chains. So intermolecular force here may be hydrogen bonds, may be dipole-dipole interaction. So if any polymer which have strong intermolecular forces between the chain in the form of hydrogen bonding or in the form of dipole-dipole interaction, then such polymers are called fibers. So there are different fibers are available. Example, nylon 6,6, terylene, and also silk. Nylon 6,6 is a polymer of adipic acid and hexamethylene diamine. And it has strong intermolecular forces. Similarly, another one, terylene, which is also a fiber, it is formed from ethylene glycol and also from terephthalic acid. It is aromatic dicarboxylic acid. And another fiber is silk, which is actually a natural fiber. So fibers are polymers where intermolecular force is very strong, and intermolecular force due to either hydrogen bonding or dipole-dipole interactions. It may be nylon 6s, maybe terylene, maybe silk. Silk is a natural fiber. Nylon 6s is a synthetic fiber formed from adipic acid and hexamethylene diamine. Why it is called nylon 6s? Because both the monomers, adipic acid and hexamethylene diamine, contain 6 carbon atom each. Third one is terylene, which is also a fiber formed from glycol or ethylene glycol. So this is structure of ethylene glycol. And another one is terephthalic acid. So this compound is called terephthalic acid. So if polymerization takes place between ethylene glycol and terephthalic acid, then we get terylene. So this is all about fiber where strong intermolecular forces between the chains. Our third example is thermoplastics. So thermoplastics are polymers which is softened on heating and hardened on cooling. So here intermolecular forces between elastomers and fibers, that is more than elastomers but less than fibers. So there are different types of thermoplastic. Examples say polythene, say polyvinyl chloride, and also Teflon, polypropylene, which is also an example of thermoplastic. So thermoplastics are polymers which are easily softened repeatedly when heated and hardened on cooling. So here recycling is possible, and here intermolecular force between elastomers and fibers. So there are number of examples of thermoplastic, polythene, PVC, Teflon, etc. Our fourth one of polymer on the basis of molecular forces is thermosetting polymers. So thermosetting polymers are polymers which undergo permanent change on heating and contains extensive cross-linking. Cross-linking means one chain linked with other chain with number of points. So such link is called cross-linking. So thermosetting plastic or thermosetting polymers which undergo permanent change on heating. That is, here recycling is not possible because of extensive cross-linking. So there are number of examples available for thermosetting polymers, which may be bakelite, may be methyl formaldehyde resin, and both of them contains large number of cross-linking. So our next question is, what is difference between thermoplastic and thermosetting polymers? So there are number of points available, but main point in case of thermoplastic, where repeated heating and hardened on cooling is possible, and here heat treatment takes place once, that is cannot be recycled, and there are number of examples. So in case of thermoplastic, generally they contains repeated unit, that is straight chain, there is no cross-linking, but here cross-linking takes place. So this is all about classification on the basis of molecular forces, elastomers, fibers, thermoplastic and thermosetting polymers. So next we move our fourth classification, that is classification based on mode of synthesis. So on the basis of mode of synthesis, polymers are classified into two types. Number one is called addition polymer, and second one is called condensation polymer. So there are two types of polymers on the basis of mode of synthesis: addition polymers and condensation polymers. So first we consider addition polymers. So in case of addition polymers, where large number of repeating units are formed, and here unsaturation is essential for monomers. So essential condition is monomer must contain either double bond or triple bond. So if any compound, say ethene, contains double bond, say vinyl chloride contains double bond, say styrene contains double bond. So if double bond or triple bond is present in monomer, then here product is called, or polymer is called addition polymer. So in this case, ethene monomer where unsaturation present, and it is called polyethene. Same chain is repeated. So this is vinyl chloride, again unsaturation present. If polymerization takes place, then we get polyvinyl chloride. It is also an addition polymer. Third one is styrene. If polymerization takes place, then it is converted to polystyrene. So essential condition for addition polymer is monomer must contain unsaturation, that is maybe double bond or maybe triple bond. And all these are example of addition polymer because these are formed as a result of addition reaction. What is condition for addition polymer? Monomer must contain unsaturation, that is double bond or triple bond. So next we consider condensation polymer. So polymer where two or more monomeric units are present. Here only one monomeric unit. Here two or more monomeric units are present, and they must contain bifunctional or trifunctional group. For example, if we consider these two compounds, say hexamethylene diamine and another one, say adipic acid. So both the monomeric unit, that is hexamethylene diamine and adipic acid, both contain bifunctional group. That is, they are two functional group, NH2, NH2. Here also two functional group. So monomeric unit may contain two functional group or maybe trifunctional group. So what is condition for condensation polymerization? Monomer must contain either bifunctional or trifunctional group. So if condensation takes place, then this type of product is formed. So in this reaction, small molecule like water is eliminated. So this is formula of nylon 6,6, because this compound contains 6 carbon atom. This one also contains 6 carbon atom. So it is called nylon 6,6. So condensation polymers are polymers where formed from two or more monomeric units, and monomeric unit must contain bifunctional or trifunctional group. So one example is nylon 6,6, second example is bakelite, third example is terylene. So in this case, monomeric unit is phenol and formaldehyde, and here in case of toluene, here monomeric unit is ethylene glycol and terephthalic acid. So for condensation polymer, bifunctional or trifunctional group is essential, and during condensation reaction, small molecules like water, ammonia, HCl, alcohol, etc. are eliminated during the reaction. So next we consider difference between addition polymer and condensation polymers. So addition polymers are molecular compounds which is empirical formula of the compound or polymer is same as empirical formula of the monomer, but here empirical formula of the polymer is entirely different from empirical formula of monomer. Second point, here unsaturation is essential in case of addition polymer. In case of condensation polymer, bifunctional or trifunctional group is essential. Third point, here nothing is eliminated during the reaction. Entire reactant is converted to product without elimination of small molecules like water, etc. But here when product is formed, small molecules like water, ammonia, HCl, ethanol, etc. are eliminated. And final point, example of addition polymer is polythene, PVC, polypropylene, polystyrene, etc. Here example is bakelite, nylon 66, toluene, etc. So this is all about classification of polymers. So next we consider some preparation or some important polymers which represent under addition polymers and some polymers which under condensation polymers. So next we consider preparation of addition polymers. Preparation of some addition polymers. So our first example is preparation of polythene. So on the basis of density, polythenes are classified in two types: low density polythene and second one, high density polythene. So first we consider preparation of low density polythene. So low density polythene are prepared from, in both cases where monomeric unit is ethene. So low density polythene where monomeric unit is ethene, here also monomeric unit is ethene. But condition is different. In case of low density polythene, here temperature between 350 to 370 degrees centigrade, very high pressure about 1000 to 2000 atm is used in presence of peroxide catalyst. So ethene when polymerized between 350 to 370 Kelvin under very high pressure of 1000 to 2000 atm in presence of peroxide catalyst, then it is converted to polythene where density is less, so it is called low density polythene. So here density about 0.93 gram per cm cube. In case of high density polythene, here again monomer is ethene, but condition is different. Here temperature between 333 to 343 Kelvin is used under 6 to 7 atm pressure, and in presence of two important catalysts. One is triethyl aluminum, and other is titanium tetrachloride. So these two compounds are used as catalyst. So here again N molecule converted to polythene, which is also known as high density polythene. So here density is 0.97 gram per cm cube. So here more density than previous one. So it is called high density polythene. So this is about polythene. So our second compound is Teflon. Polytetrafluoroethane. So here monomeric unit is this one, tetrafluoroethane. So tetrafluoroethane, when polymerized under high pressure, in presence of persulfate catalyst. So here N molecule combine and form product which is known as Teflon, also known as polytetrafluoroethane. So our last compound is polyacrylonitrile. So for preparation of polyacrylonitrile, so here monomeric unit is vinyl cyanide. Or acrylonitrile. Vinyl cyanide is also known as acrylonitrile. So when it is polymerized in presence of peroxide catalyst, so here again N molecules combine and form product which is known as PAN, polyacrylonitrile. So these three are examples of addition polymer. Number one, polythene, if density less, that is 0.93, it is called low density polythene, and if density more 0.97 gram per cm cube, then it is called high density polythene. Our next compound is Teflon, where monomeric unit is tetrafluoroethane. If it is polymerized under high pressure in presence of persulfate catalyst, then we get Teflon. Our last compound is polyacrylonitrile, which is also known as PAN. So it is prepared from vinyl cyanide or acrylonitrile in presence of peroxide catalyst. So this is all about addition polymer and preparation of addition polymer. So in our next class, we consider condensation polymer and also preparation of condensation polymer. Okay, thank you.